All right, so today we're going to be talking about inheritance. So we've seen classes. We've made classes. We have a class, then we can create a whole bunch of instances based on that class. So if we have a basic blueprint that we want, we're going to make a whole bunch of things. They're going to conform to the same basic pattern. We can abstract that into a class instead of just creating isolated objects. But there's some additional richness or functionality that you can get, and you can get that through inheritance. So sometimes you want your classes to also perhaps share attributes with other classes. So you can kind of apply that same basic logic to classes themselves. So we'll take a look. If you want to go through this README, that's fine. So this will be kind of talk about the same stuff, but we'll go through a different example. We'll talk about Pokemon. Just coincidentally. So I don't know anything about Pokemon. Well, I guess I know a couple things, but let's do. So let's make a Pokemon class. I guess Jess should start.
I really should, huh? It's so you start with lowercase class, class, and then capitalize the word Pokemon, and that'll be your name of your class. And then you'll do a colon, and then you on the next line you can start writing it. Probably want to start with def init.
Okay. So tell me about def init.
So def init's going to run every time a new instance of Pokemon is created, and you need to put self in there.
Right.
And then a colon.
And sorry, what is self?
Self is referring to the instance. I don't know how to say this, but the instance that we're in, or the instance that we're working on, or
yeah. So an instance that will be created from this class.
Right. So okay. Then you'll put your colon after that, and unless you want to take in any other parameters.
Okay. So what kind of thing should a Pokemon have? Maybe just one or two things.
It should have a type, which
okay.
is like fire, water, steel, plant, grass.
Okay.
Then it should have, they're usually pre-evolved or post-evolved. So I guess that would be
okay.
Evolution state, maybe.
Okay. Well, if there are only two possible values,
there are technically more than that, but basically two.
Oh God. Okay.
Yeah.
There's up to three normally, and then there's mega evolutions and more.
Okay.
So I'm so glad you're on here with me.
You could go attack or hit points.
Yes.
All right, let's go with stage. I'll go stage.
Perfect. And then here you're going to want to put your the variables that are constant for every. For every instance of it. So if they all start out at level 1, you could do starting level 1 or something like that. Or would that go above?
Yeah. So so that's a good question. So let's say that type will always be, I guess, potentially be different for every instance, right? So we'll always want to specify type. So let's start with that.
Self.type equals type.
Equals type. And stage. So if every Pokemon starts at level 1, but then presumably individual Pokemons will change. So I'll open it up to other people. Should this be a class variable or an instance variable?
Well, there's also two different things. There's the level that starts at 1 and the stage is like, is it stage 1 or stage 2? It changes shape, like form, essentially. It's like a baby
Okay.
and a grown up.
Okay, so
Level.
let's go with level then.
Yeah.
So level, so they all start at 1.
So,
Anyone
They
else?
do not necessarily start at 1.
well, they're born, I would think they hatch from their egg at 1.
All
But
right,
you might-
let's try to
Sorry.
keep this simplify. I know it's gonna be tough for some of you, but let's try to simplify the world of Pokemon just a little bit. So let's assume that we have a level. Let's assume that all of them start off at level 1. Should this be a class variable or an instance variable?
It would be a class variable because they're all the same.
Okay.
They're
Any
all
other?
starting from the
Okay, so they're all the same. So Jess thinks they should be a class variable. Does anyone else have any thoughts?
If we want to identify the level of each one, it's got to stay there.
Can you say a little bit more?
So when we start creating our Pokemon, we're going to
Mhm.
put in their X type, and then we're going to put in what level they are. So that's going to have to go there, where it is.
But if they all start at 1, we could do something like,
Okay, then we put out there then, I guess. Yeah.
we could do that. Okay, so let's try this real quick. So I'm gonna create an instance. So someone who's not Jess, how do I create an instance of a Pokemon?
Just gonna name it. So whatever you want to name your Pokemon, and then equals Pokemon.
Okay. And then we'll have a type, so fire, I guess, and then we can
We don't have
check.
any methods to call with it, so
Yeah.
I guess you can check the type out though.
Not
just
yet.
by going p.type.
Sure. I can also do p.level. Okay, so that makes sense. Fire level 1. And I'm going to create another Pokemon. This will be water. All right. So now I have 2 Pokemon and they both start at level 1. That's great. Okay. Let's just say, Pokemon fire, this guy levels up. Pokemon 1 levels up. So p.level equals 2. We do that here. So this will, okay, so there's a couple issues. One there's mutable types and immutable types. So this actually might work, although it will work without really representing what we want. So if we create a class, if we create a class variable, what we're saying is every single instance that's created from this class will be level 1. So do we want all Pokemon to always be the same level? Right. So that's the level of the Pokemon would be something that would change for each instance, right? So that would be an instance level thing. So if that might be, this is not really the right data type, but if I did something like this, so unfortunately, or I guess fortunately or unfortunately, ints are immutable, so it will create a new one if you change it. But here I use an array. So this is a reference here. And so if I change one instance's level, it will change that for all of them. So now the water guy is upgraded even though he hasn't actually progressed to the next level. So you don't want to do class variables. It's usually going to be something like a constant. We don't want to do that. What we can do is put that in here and say level equals 1. You do something like this. So when we first assign it, this, if we don't pass in a parameter, they'll all start at 1. This way I can change, let's see, P. And this will be what we actually intend, right? Because every instance is going to increase in level according to its own, its own stuff. Okay, so we have a Pokemon and they have a type and a level. What about attacks? Do Pokemons have attacks? Okay,
Yes.
so let's do
Up to 4 at any given time.
okay. So sometimes domain-specific knowledge is very helpful when you're designing an application. So attacks, let's just do attack. Again, I'll oversimplify, just say they have one attack. And then here's an issue. Does every Pokemon have the same attack? Is there any kind of general? Do all Pokemons have any kind of, do they start out having the same attack or anything like that?
No.
No.
Okay. So you might do something like so I don't want to talk about abstract base classes or abstract methods right now, but this would be for if anyone happens to know, be familiar with those, this would be an abstract method. But let's forget about that. So what we've done is we've created like kind of a basic Pokemon, right? So any Pokemon should be able to attack. Any Pokemon should have a type and a level. But the problem is that there isn't a specific Pokemon that really will work for this, right? So what we need to do is create subclasses. So I think Charmander. Let's create a Charmander class. Charmander. And we could rewrite Charmander as an independent class, right? Because Charmander will have a type and a level and will have its own attack and anything else we want, right? But then we're kind of, again, we're rewriting stuff. So we can use all of the stuff that we wrote for this general Pokemon, and we can use it in the Charmander. So, and what we're saying here is that we want our Charmander class to inherit from this Pokemon class. So everything that this Pokemon class has should be available to the Charmander. So we don't have to rewrite this stuff. There's a slight catch, especially with the init. So let's say that Charmander has a type and a level and I don't know, a shield or something. So I'm sorry if that's painful for true fans. We're going to say that he has a shield. Self. So when you create an instance of Charmander, it's also going to you have to provide it the type, a level, if the order might be significant here. Yeah, we'll see if I can do this. And then order, a level, and a shield. Actually, we'll assume that we can specify that. So the trick here with Python is that we have to explicitly tell our subclass to call the init method of its superclass. So there's a few ways we could do that. One is we could do Pokemon.init, and we'll do type, level, and then self dot, I don't know, something like that. So let's try creating an instance of Charmander. I'm going to assume fire. And level, let's do, yeah, that should be fine. C dot shield. String is no. Let's see here. Let's try that. I think the default parameters throw me off here. Self.type equals type. String object has no attribute type. I'm a little confused here. Does anyone see what's?
Does Pokemon init need a self too? Like on line 15 as the first parameter? I don't know.
It shouldn't. But maybe. There you go. Thank you. So we call, so here we're calling our superclass specifically. You can do that, but it's not really the recommended way. There's a more general way of doing that, which is to use super. So in this case, it'll do the same thing. The super will be Pokemon. So we call super,
Then can you get rid of the self now?
Yeah,
I think so. Yeah.
Okay.
thank you. So, so this would be the standard way that you would want to do this. So you call super, which will refer to the super class which you're inheriting from, and you call the init function there, and you get access, and you have to specify the values that are coming that should come from the base class, and then anything else you do can come after.
So you don't have to bring in attack because it's not something that is a variable. It's not a variable or a parameter.
Yeah, so let's will we be able to call attack on a Charmander?
You should be able to call it. So it's just not being. You don't have a parameter for it because there's nothing to give it. Is that right?
Yeah, so you wouldn't call it with a parameter, right?
And then I noticed that when you had on line 15, when you had Pokemon there instead of super, it was just the word Pokemon, and now it's a method.
Yeah, this is a more this is a newer way that Python that you should be handling this in Python. So super will refer to the superclass, which in this case is Pokemon. So this is just doing the same thing as Pokemon, basically. And you can also do the same thing. So for example, let's say we want a Charmander to have its own special attack. So we could just write a new method. We could do something like def Charmander attack, or something like that. But then we're going to lose. So again, you could do that. But if we want to keep this API kind of consistent or coherent, we want every Pokemon to be able to attack, or at least as many as possible. Then what we can do is override this attack. And then, I don't know, we'll just do something like that. And now Charmander's attack is this fire attack. So because the way this works is they're basically going to be a series of lookups. So if you create an instance of Charmander and you call the attack method here, you're basically saying, hey, Python, find me something called attack. So Python is going to start here. It's going to start in the instance and start looking. Hey, is there anything called attack? And if it finds it, it's gonna use the first one that it finds. If it doesn't find one, then it's gonna look here in the immediate environment and say, is there an attack? Nope, there's not. So can I look anywhere else? Well, yes, I can, because I'm subclassing from Pokemon. So I go up to Pokemon and I look for attack. Is there attack? Yes. So I use Pokemon's attack instead of Charmander's attack. This is one way of creating kind of a flexible or a stable API or shape. If you want to have a class, and then you want subclasses to all do attacks of one sort or another. Maybe there's some shared functionality. Maybe there isn't. What if so we just saw super appear in the init. If we want to call actually call Pokemon's attack method, we can do that as well. So we can go so now when we call a Charmander's attack, this is the method that gets called. And here, the first thing we do is we say, hey, superclass, I want to call your attack method. So we call the superclass's attack method and we get an attack. And then we just run the rest of the method here. So here we're overriding the method and then we're calling it anyway. So there are times when you want to do that. You might want to slightly modify the functionality of a parent class's method. Are there any questions about that?
Can you show us another example, like using animals?
I mean, Pokemon are animals.
Okay. Okay.
Let's do another example. What's a Pokemon that has an animal that sounds like it's an animal, a real animal? Is there like a dolphin Pokemon or something?
Eevee.
You know an awful lot about Pokemon, Chad. I'm starting to think you're a closet Pokemon person.
I
Just doesn't
swear,
want to admit to it.
I swear I'm not. I swear I'm not.
Like a dog or a cat?
Meows.
All right, Meowth. I like it. Is it Meowth?
MEOWTH, I think.
Okay. Like that?
Yes.
Okay. All right, Deb. Sorry, this is the best I can do.
Okay.
I was in like 4th grade when this game came out. So I know it all.
So Meowth, let's I guess we can think of him as a cat if we like, but so Meowth is a Pokemon, right? Is a Pokemon. Same with Charmander. Charmander is a Pokemon.
Yes.
So the inheritance relationship you can describe as is a. So a Charmander is a Pokemon. A Meowth is also a Pokemon. So
Right.
Meowth can inherit from Pokemon because Meowth is a Pokemon. So it can do all the things that a Pokemon can do. And we'll do def init. I guess we'll do and well, we'll just do this. And what's something super? So again, we'll do the same thing. We'll have to call the Pokemon init. And then you could say that a Meowth has a cuteness factor. And let's say that cuteness factor is 10. All right, so it's level 10 cuteness. So we have a Meowth, and this is it also is a Pokemon. What about a method? Let's say Meowth. Let's say it doesn't attack. Let's say it, I don't know, purrs. You purr, and then that's not really purring. So as far as I know, there's no way to like cancel. You can't like cancel a method, but we could do something like so it won't really do anything. So let's create an instance of Meowth, and it'll be Earth, let's say, and we can call m.per. See what happens. I'll comment these out. So when I call m.per, it purrs. What happens if I call Charmander's purr?
Not defined.
Yeah, so Charmander can't purr. What about Pokemon? Can Pokemon purr?
No.
Yeah.
He's in the subclass.
Yeah. So far only a Meowth can purr. And what happens if we try to attack?
Nothing. Or is it going to default to the other attack?
Well, we've overridden it here. So if we don't override it, then all of a sudden it can attack, but it's the Pokemon's attack, right? Not the Charmander's attack, it's the Pokemon's attack. So we can have a subclass that we can add any number of other properties or extra methods. We can override methods. So you can really customize things. But if you start making Pokemon and you realize that, hey, all of these Pokemon, they seem to all have, a name or a type or a level, instead of just creating individual Pokemon classes, you can, again, take all of the common features and, form a base class from those features. Yeah.
It seems like another way to think about this is with the types. Like if you have a fire type and a water type, they're going to have similarities. So that might be a good use of a
Sure. Yeah.
Fire and then Charmander.
So we can keep going. So we can have a Pokemon class, and let's say have a water Pokemon.
If we were doing real animals, it would be like animal, mammal, or animal reptile. That would work too if you were.
Yeah. But we can create, so let's just do that real quick. So I'm going to copy this. I guess in this case, the type would be let's try creating instance of water Pokemon. We don't need anything.
You didn't put Pokemon in the parentheses after water Pokemon, class
Thank
water
you.
Pokemon.
Thank you very much. Okay, so that works. If I test water Pokemon's w.attack, and attack, let's override water Pokemon's attack. So I want to have a water attack for all water Pokemon. How do I do that?
Would you just do def attack self and then rewrite it as you would want to?
Yeah.
You just write water attack instead of an attack.
Exactly. So we'll do a water attack. And then so water, and then it's Charmander. Which one? So let's say Meowth is a water Pokemon now. So I'm going to get rid of Charmander. Sorry, everybody. So now I have Pokemon, a Pokemon class, which is, you know, like a very generic class. I have another subclass, Water Pokemon, which is another kind of level of abstraction. And I want to create an individual Water Pokemon. I can inherit from Water Pokemon. And Water Pokemon inherits from Pokemon. So I can chain this inheritance together. You can get multiple levels of inheritance.
And so now, since Meowth is a water type, if you didn't have the attack being canceled out there, it would do a water attack. But since you did have, well, but before you deleted that, it would still not do anything, because even though it has 2 attacks above it, in the super classes above it, it still is canceled out there on 20.
Would anyone like to try answering that question?
Yeah, I think it would still pass because the attack's going to overwrite the other 2 upper ones.
Okay. So as it is right now, our Meowth can't attack.
Oh, but you
shouldn't-
set it to Earth type.
Let me hold on. That shouldn't have happened. Meowth. I'm gonna have to change this. So type level. Level 1. Type water.
Are you looking for a different parameter instead of type?
Let me try this for now. I'm still confused. This should not be water Pokemon. Meowth inherits from water Pokemon. Sorry. Jeez.
So that was not Meowth's attack that was coming through, it was the
Yeah.
water.
Yeah, sorry. So right now, so we create an instance of Meowth right here. And we call this instance's attack method. The first place it's going to look is within itself, and it's going to find attack. So it's not going to keep going up. It's going to stop as soon as it finds what it's looking for. If we comment this out, and it doesn't have its own attack method, it's going to go up 1 level. So in this case, it's going to look in water Pokemon and see, oh, there's an attack. I'm going to call that one. So it calls water attack. Now, what if water Pokemon doesn't have an attack?
Then it'll go all the way up to the super class of Pokemon.
Yeah. So it's going to keep looking up. It's going to keep looking up until it either finds what it's looking for or it reaches, you know, none at the end of the chain.
I'm just curious, could you call the per method inside of the attack method instead of, like if you wanted it to per instead of attack, could you put that inside?
Sure. I mean, you could do something like,
Because it's already defined.
yeah. You could even, again, you can call the water Pokemon's attack as well. So it does water attack and then it meows. So we can keep playing around with this stuff, but the basic idea is So the first like most naive level is not even use classes, right? So if we want to create Pokemon, then we just do something like, I don't know. We do equals, we create an object, and we do, I don't know, type fire, we do so we could just make a Charmander just by itself, and we could then we could create you know, whatever, a Meowth, and we could just create, you know, every individual object is totally, it starts from scratch, right? But this is obviously not quite as dry. It gets very repetitive after a while. So we move one level up. Let's make a class. Let's make a general Pokemon class, because every Pokemon is going to have an attack and every Pokemon is going to have a type. So we do that. And then at a certain point, we realize, hey, wait a minute, there's some more refinement we could make. So it turns out that water Pokemon also have a lot of things in common, and fire Pokemon have a lot of things in common. So you can start grouping things together, and you create an inheritance hierarchy that makes sense.
And then on top of it, every time you create an instance, that's its own, it's, you know, it's its own level as well.
If you create an instance, yeah,
Like two Charming gave them some kind of different.
yeah. So any instance you create will be its own object, so it can have, you know, properties and methods. And
So what if you want to do some mathematical calculations with classes, and you want to, what would that setup look like?
okay, so let's say we wanted to have like a statistics class. I should preface this by saying I am terrible at math, and
Like if you want to calculate the length and width of a rectangle.
yeah. So let's have a class length and width. So do you want this to be a standalone class or to use inheritance?
Yeah, standalone class.
Yeah, so let's just say area something.
We put length and width there. Yeah.
Do something like that, and then we'll do, let's just do a, equals so we get 8 there.
Oh, good. Thanks.
And then you could also add other functions. We could subclass this to calculate, you know, it would be a little bit, maybe a little awkward in some cases, but you could calculate the area of a triangle. So you could subclass this maybe. You could also add other methods. So there are different ways of potentially organizing something like this. All right, so are there any questions about inheritance?
When you were mentioning doing area and triangle, that might be a reason to do a subclass because so area, this class that we just made, it seems more abstract and more about the functions and methods versus the one that was things. Does that make sense what I'm getting at?
Yeah, yeah. So yeah, a lot of these kind of the, first examples you'll see are obvious, to some extent it's a little bit, the actual classes are a lot more abstract. So you're doing stuff like a socket. So what is a socket? What is a file? So you create like a file class and then you can do other stuff with it. So it doesn't map onto something physical in the same way. We'll do def init. We need base and height, is that right?
Well, if you still had length and width, you would call it base and height then.
Yeah, so so we could potentially just ignore, we could do something like, let's try. Let's see if this works.
Oh, and then after on line 65, you have to put area after triangle area, right?
Sorry, what?
On line 65, don't you need to put in parentheses after triangle?
Yes, yeah, thank you. We need to hear it from area. Just try doing this, see if it works. Self dot. We'll do, I don't know what the formula.
It's just 1/2.
Okay.
1/2 base times height. So you could do 1/2 of calculate somehow, I think, right?
Yeah, actually, I think we could do that. We could do return super dot calculate. In this case, it's a bit weird because I'm trying to rename it. It's the same thing, but divided by 2. So this is not necessarily the best example. So instead of let's do triangle.
I think on line 69, it needs to be self
Oh,
dot
whoops.
width.
Thank you. I'm not. I'm trying to do something that doesn't make a whole lot of sense right here, but it might require a little bit more thought than what I'm giving it. But so it returns the correct number. In this case, the internal term is not correct.
But that might make sense if you're looking for the triangle's base at some point, if you wanted to call that particular attribute of a triangle, then it makes sense for you to be calling base instead of length.
Yeah.
But you have to use length and width for the superclass in line 67 because that's what it's called in the superclass. You
Right.
couldn't do that to whatever you want.
Yeah. So this is, reworking this to be a little bit more sensible would require some thought off the top of my head. aside from just rewriting the calculate method entirely. You know, we could talk about whatever would make sense, but the basic idea that you can inherit so this is the method that's getting called directly from this instance. We create a triangle instance. It calls this method. It just so happens that inside the method, we're calling explicitly this calculate method. And then we're dividing that by 2. Any more questions? Does anyone else have basically no idea what's going on in terms of inheritance? So I can create a class and then I can, yeah, I guess that's unfair. No one will want to admit that, but if you don't have any idea, that's fine. This is a new concept. So you have a class and then I want to preserve, instead of repeating myself and creating an entirely new, you know, animal or Pokemon or, you know, shape area calculator, I can borrow stuff that already exists elsewhere instead of writing everything from scratch.
Which is the reason we'd want to build in a class in the first place, right?
Yeah,
So
exactly.
Okay.
So it starts, so again, like, I guess I erased it, but, oh, here we go. So the like first level of trying to do this would be, okay, I want to create a Charmander. And then, oh, I want to create a Meowth. Oh, I want to create whatever. So I start by creating a bunch of these objects, and I realize, wait a minute, I'm creating a whole bunch of objects. There are some similarities. Let me pull out these things that are the same, and put them in one place into a class, and then I can create instances and then specify just what's different about every instance. And if you start doing that, and you realize, hey, there are these other groupings, right? There are water Pokemon. There are, I don't know, maybe in terms of geometry, things that are round and things that have angled lines. Those are different. So I'll put those in 2 different classes. So it's just a way, like the bottom line is it's a way of preventing you from repeating yourself in code. So instead of writing the same thing in 5 different places, you can put it in one place or as few places as possible. All right. So let me go over the challenges for today.